Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd Edition by Briggs, Cochran, and Gillette. This video is actually going to take care of the last two properties of derivatives covered in section 3.3, and we're going to hit the constant multiplication rule real quick, and then we're going to do the summation of two functions. So really what I'm saying here is if I have something multiplying the function, then I take the derivative of the function and I just multiply by that constant. So an example of this is y equals 2x squared. Now, this seems kind of obvious, but I do want to take a minute and show you where the logic comes in from the definition of the derivative. Number one, I want to note that well, I don't want to write it like that. Let's say d dx of x squared is 2x from the power rule, which we learned in our last couple videos, which is the best. This is like the He-Man of calculus. It has the power. Now, that was terrible. If I want dy dx, where y is 2x squared, that gives me 2, the limit, as h goes to 0, of 2 times x plus h, quantity squared, minus 2x squared over h. Now, if I am careful here, I'm gonna cheat a little bit. This is factoring out this 2. I've got the limit as h goes to 0 of 2 times x plus h squared minus x squared over h, and by rules of derivatives, this is twice the limit as h goes to 0 of that, so x plus h squared minus x squared over h. And hey, look, see here, this by definition is the derivative of x squared, so that's 2 times d dx x squared. Didn't have to do all that horrendousness, and I really just come down to, well, what's the derivative of that? That's 2 times 2x, which is 4x. So a constant out front, I'm just multiplying through, everything's hunky-dory. Now, the next one's actually really important because as we get into more and more complicated polynomials, the ability to break them up is going to be really important. This says if f and g are both differentiable at x, then the derivative of the sum is the sum of the derivatives. Wow, that's fun to say. The derivative of the sum is the sum of the derivatives. Here's what this means. Let's pretend your calculus teacher is mean. I am not mean because I'm clearly above average, and if you caught that joke, you're in the right class. I'm going to say f of x equals 4x cubed plus 3x squared. Now, doing this with the limit definition of the derivative might be the worst thing ever. I'm not even going to show it to you because you'll have nightmares. Okay? I want to evaluate df dx. Now I'm going to cheat. Number one, I'm going to come over here and I'm going to say g of x equals 4x cubed, and h of x is 3x squared. Notice here that f of x is g of x plus h of x. Now, this is where this is really nice. df dx is really just dg dx, the derivative of g, plus the derivative of h. Now, we can use a combination of that constant multiplication thing we just did. We can say that dg dx is 4 times the derivative of x cubed, and we said with power rule that the derivative of x cubed is 3x squared, so the power comes down, and take 1 away from the power. So that's 12x squared. dh dx is 3 times the derivative of x squared. The derivative of x squared is 2x. I've got 3 times 2x, or 6x. So the derivative of f is 12x squared plus 6x. And I'm done. I am done. Like, that's it. That's it. There's nothing crazy. I haven't broken anything. Math is happy. Math is good. I hope you have found this video useful. Good luck in the course.